Namaste and a very good evening to all of you. I welcome you to my channel, The Outlier. My name is Mithun. In today's video, I'll be talking about price elasticity of demand. We'll be looking at what is the concept of price elasticity of demand. I'll also go ahead and build an appropriate model to learn the characteristics of demand as a function of price. Even before I proceed to demonstrate how to model price elasticity of demand, may I request you to subscribe to my channel, also like and share my videos. The first few moments I like to use to talk about what exactly do we mean by price elasticity of demand. It's a mouthful of words. Let's just break this down and understand this in parts. What do you mean by price elasticity of demand? Where is it used? How can we make sense of the output produced by the model? To answer this question as to what is the price elasticity of demand, remember, price elasticity of demand is a measure that has been used in econometrics as well as finance. Why do we use the price elasticity of demand? The price elasticity of demand is used to show how demand for a particular product changes when the price of the product is changed. It's a very simple phenomena. When you change price of any particular product, what is the impact that it has on demand? If I increase price, how will demand behave? Will demand also increase, or will it decrease, or will it be static? This is exactly what we are trying to study when we talk about price elasticity of demand. More importantly, price elasticity of demand measures the percentage change in demand of a product when the price changes by 1%. I'd like to repeat this. Price elasticity of demand measures what is the percentage change in demand of a product when you increase the price by 1%. It can be expressed using a simple formula. The formula that we are going to use is percentage of delta quantity divided by percentage of delta price. So in the numerator, we are taking percentage of delta quantity, and in the denominator, what we have is percentage of delta price. What this simply means is when you give a small increment to price, what is the corresponding impact that you observe on quantity? So this is at the heart of price elasticity of demand. Let me move to the example section. In the example section, I will be talking about a very simple instance of demand for the Bluetooth headset. We are going to talk about the demand for Bluetooth headset and are going to understand how price elasticity of demand can be comprehended using this particular product. Let's consider a hypothetical situation. In this hypothetical situation, let us say that the demand of a particular Bluetooth headset decreases by 2%. The operative word here is decrease by 2%. So demand will be minus 2% when the price is increased by 1%. So delta price is plus 1%. On the other hand, delta demand is minus 2%. If you know these two quantities, it becomes very easy for you to estimate the price elasticity of demand for the Bluetooth headset. How do you estimate the price elasticity of demand? It is simply the ratio of minus 2% and 1%. When you take minus 2% and 1%, the ratio is minus 2. And hence, we can conclude by saying that the price elasticity of demand in this case is minus 2. Now that we have taken a simple example, let's now move on to the interpretation of price elasticity of demand. How do you interpret the answer that you obtain from the price elasticity of demand. There are two cases that we can study here. The first case is when the price elasticity of demand is greater than 1. The second case is when the price elasticity of demand is less than 1. Let's take the first example when the price elasticity of demand is greater than 1. What does this indicate? Remember, whenever the PED or the price elasticity of demand is greater than 1, it shows a highly elastic product. I repeat, whenever the PED is greater than 1, it shows a highly elastic product. This product is very sensitive to change in price. In other words, the change in price will cause a more than proportionate change in demand. So these are a class of products wherein you need to be very, very careful about changing the price, because the moment you increase price or make any changes to price, you can expect a dramatic impact on demand. And therefore, we need to be extremely sensitive. We need to be extremely careful for those products which have a PED of greater than 1. Now, one question that you might ask me is, when do you see PED value of greater than 1? Let's say 2 or 3 or 4. You may get a PED of 2 or 3 or 4. Generally speaking, PED value will be greater than 1 when you are talking about non-essential or luxury products. Remember this, whenever we are talking about non-essential or luxury products, you can expect the PED to be greater than 1. Let's now move on to case number 2, wherein we are talking about a PED of less than 1. When I say less than 1, the value could be 0.5 or 0.8 or 0.2. In many cases, it can be negative as well. How do we interpret a case wherein the PED is less than 1? Whenever the PED is less than 1, it indicates that we are dealing with relatively inelastic products. I repeat, if the PED value is less than 1, it strongly indicates that we are dealing with inelastic products. Typical examples of inelastic products are grocery items and daily necessities. Furthermore, for a more productive, my apologies, let me read this out again. Furthermore, for most product, PED will be negative. This is very interesting. We are saying that for most of the products, PED will be negative. That is, when the price is increased, demand falls. Let's just break this down. Why do we say that for most of the products, PED will be negative? This is because the moment you increase price, in other words, if price increases, it simply means that you're making a product more expensive. If you make any product more expensive, consumer psychology is such that they buy lesser and lesser of such a product. Therefore, we expect an inverse relationship between price and demand. And hence, for most of the products, PED will be negative. A curious exception to this rule would be the gift-on goods. Let's now talk about how do we apply the price elasticity of demand. There are 3 important points to be stated when we speak about the price elasticity of demand. The first is price elasticity of demand depends on time. I repeat, price elasticity of demand is a function of time. What does this statement mean? This simply means that when we are talking about price elasticity of demand for a given product or product category, PED for a given product or PED for a given product or product category can change over time. And hence, it is very, very important for us to measure PED over a period of time. So remember the first point, PED is a function of time. The second point here is that PED is also a function of customer segments. PED for a given product or product category can vary by customer segments. What does this statement mean? This means that the poor people may react to increase in price in a particular way. The middle class people will react to increase in price in a different way. The same argument holds good even for the rich and affluent. Their reaction to increase in price may be totally different. And hence we are saying that PED for a given product is not a constant for different customer segments. It will vary for each and every customer segment. For example, a low income customers, I repeat, for example, low income customers or poor people may have a higher PED for the same product. The opposite is also true, that the high income customers may have a lower PED for the same product. The third important point here is pricing of a product should be optimized, taking into account the PED. For example, if a product is showing lower price elasticity or is simply inelastic, pricing can be increased on the product to maximize revenue. What we are trying to say in this point is, how do you evaluate what is the optimal price of a particular product? You may say that for a particular Bluetooth speaker, you want to price it at X dollars. How do you arrive at that number X? Why not X minus 100? Why not X plus 100? What is the optimal price for a particular product can be decided only after performing price elasticity of demand. And we strongly recommend that you take into account PED or price elasticity of demand when you decide on the ideal price for a particular product. Let's now see how to build a model for price elasticity of demand. Even before I proceed to demonstrate how to build a price elasticity of demand model, I'll quickly show you the data set that I'll be using to build the price elasticity of demand model. As you can see here, this is the spreadsheet. In this spreadsheet, I've got the base data. There are 4 columns in this particular data set. The first is year. The second column here is quarter. The third column is quantity. And the fourth column here is price. So if I were to take a pause and ask a simple question, which will be the dependent variable in this data and which will be the independent variable, what would your answer be? Your answer would be that quantity demanded, quantity of meat demanded will be the dependent variable and price will be the independent variable. We are saying this because we are going to change price and we are going to study what is the impact of change in price on the quantity demanded. This data set is called as beef price elasticity data. Let me apply a simple filter here. Let me look at the window period of analysis. As you can clearly see here, the data starts from 1977. When I scroll down, you can see here the last year is 1999. So we have 22 years of data in this example. I repeat, we have 22 years of data in this example. The data is given at a quarterly level for quantity of beef demanded and the price that is placed on beef. I will be using Google Colab to build a model for price elasticity of demand. Let me come back to Google Colab. In the first step, as you can clearly see here, what am I doing? What I'm doing here in the first step is to import the data. Typically, how do we import data? You can load the pandas library. Within pandas, there's an interesting function which is called as pd.read_csv. So the read_csv helps me read the CSV file. I've specified the name of the data set which I'd like to read, and I like to display the first 5 records of this particular data set. You can see here year, quarter, quantity, and price. These are the 4 variables which we have imported into Google Colab. The first record here refers to first quarter data for the year 1977. We are given quantity and price. Similarly, for the second quarter in the year 1977, what is the quantity of beef demanded and what is the price that is given. Like this, we have 22 years of data. One of the first things that we do is to perform what is called as EDA or Exploratory Data Analysis. Here, we use different tables and graphs to show the relationship between the dependent and the independent variable. I like to create a simple scatter plot to study how is quantity affected by changing price. As you can see here, I'm importing the Seaborn library. I'm also importing the matplotlib library. Then I'm using a simple command which is called as sns.pairplot. What this does is it will create a scatter plot. As you can see here, along the x-axis, I'm using price because this is the independent variable. And along the y-axis, I'm using the quantity of beef demanded. Let us see what is the output of the scatter plot. Let me scroll down to show you the result of the scatter plot. You can see here along the y-axis, what we have is quantity. If I scroll below, my apologies. Let me scroll below. You can see here, this is the price which is changing. Clearly, when you look at the minimum value of price, it is 140 units and the highest value of price is 300. When price is very, very low, that is 140 units, you can see here, demand is at its peak. The quantity demanded is close to 23.5 units. So this agrees with our common sense as well. Since it is very cheap, the quantity demanded goes up. But consistently, you see the quantity drop down. The quantity of beef goes down as the price increases from 140 all the way up to 300. So this is what we expect for any product in real life situation as well, that as you go on making a particular item more and more expensive, its quantity, the demand for the quantity keeps on falling. So this is what we are getting here. We see continuously and consistently demand falling. So even before you build a model, you can almost predict that the price elasticity of demand in this case will be negative. But what is the right number? We need to quantify that. Let's just quickly quantify that with the help of a model. In the next slide, what I'm going to show is to build a log-log linear model. I repeat, we are going to build a log-log linear model. What we are going to do is we are going to import what is called as statsmodels.api. Similarly, we can also import statsmodels.formula.api. The third library which I'm going to import is NumPy, followed by warnings. We can use a simple function which is called as smf.ols. SMF stands for stats models formula. I repeat, stats models formula, and OLS stands for ordinary least squares. You can see here we are applying the log transformation. The log function is present in the NumPy library. So we are going to use np.log on the dependent variable, namely quantity. This is very, very interesting. We are modifying the dependent variable. We are not using the dependent variable as it is. We are taking a log transformation of the dependent variable. Then you have a tilde symbol here, followed by np.log of price. Very interestingly, we are going to apply a log transformation on the independent variable as well. So we are going to apply log transformation not just on the dependent variable, but also on the independent variable, namely price. So this is why we are calling this as a log-log linear model. You have to specify the name of the data set, and you can go ahead and use the fit function. This will run the model and share, my apologies, this will run the model and save the results in an object which is called as LM. If you want to see the output of LM, what you can do is you can run a very simple command. The name of the command is summary function. You can just say lm.summary of. When you execute this, Google Colab prints a lot of results. You can see here, the heading is OLS regression results. As I already told you, OLS stands for ordinary least squares. It displays the dependent variable as log of quantity. The model that is used is OLS. The method is least squares. The date on which we are running the model, the time of execution is displayed, the sample size or the number of observation is given, the degrees of freedom for residuals is given, other important details like degrees of freedom for the model is given. What is the covariance type? It is non-robust. Out of all these details, what is very, very interesting to me is the value of R squared. Remember, R squared stands for coefficient of determination. R squared is used to indicate the model goodness of fit. R square lies between 0 and 1. If the R squared value is close to 1, it means that the model fits the data well. On the other hand, if the R squared value is close to 0, it means that the model does not fit the data well. We are getting a R square value of 0.85. Question is, how do we interpret 0.85? 0.85 suggests that 85% of the variation in demand for beef can be explained by price. which is a very, very high number. I repeat, 85% of the variation in demand for beef can be explained by the price of beef, which also means that the remaining 15% is explained by other factors. Look at the adjusted R square. R square tends to be slightly optimistic. Adjusted R square penalizes a model for having additional parameters. The adjusted R square in this case is 0.885. Google Colab also displays the F statistic value, the P or the probability of F, which is a very, very tiny number indicating that R square is significant. Further, you're also shown log likelihood, AIC, which stands for archaic information criteria, and BIC, which stands for Bayesian information criteria. You can use AIC as well as BIC to tell the quality of the model. Let's now look at the substance of the analysis. The most important substantive part of analysis would be the coefficients that are being displayed. You're getting the coefficient value for intercept as 5.83. Look at the p-value, it is 0.000, which means that the p-value is significant. Next, you have log of price. Remember, we are not using the independent variable as it is. We are taking the log transformation of the variable price. When we take the log transformation for the variable price and look at its coefficient is minus 0.53. Is that significant? To answer that question, we can look at the p-value. The p-value is 0.000, which is clearly less than 0.05, and therefore we can go ahead and conclude that this variable is a significant predictor. So let's just spend some time understanding what does this value mean. Minus 0.53 is very, very important. We have run a model here. The name of the model is log-log linear model to estimate the price elasticity of demand. The coefficient from the log linear model shows that the price elasticity of demand between two factors. So this value of minus 0.53 shows what is the PED or price elasticity of demand between the two factors. When we look at the output value, what it says is the price elasticity of demand is minus 0.53. So the coefficient of the independent variable itself is a reflection of the price elasticity of demand. So what does this mean? Since we have obtained that the price elasticity of demand is minus 0.53, this shows that when price of beef is increased by 1%, the demand for beef falls down by 0.53%. So there is an inverse relationship between price and demand. I'd like to repeat this. Since we have obtained the price elasticity of demand as negative 0.53, it simply means that when price of beef is increased by 1%, the demand for beef falls by 0.53%. Is that significant? Since the p-value is less than 0.05, we can conclude that it is significant. Additionally, you can also look at standard error and T. You have other values like omnibus, probability of omnibus, what is the skewness value, and kurtosis. Both of these are measures of asymmetry in the data. Very interestingly, we also have the Durbin-Watson statistic. The Durbin-Watson statistic is used to check for autocorrelation. Here, the Durbin-Watson statistic is 1.107. Remember, if the Durbin-Watson statistic is exactly 2, it means that your data is free from autocorrelation. Here, I'm not getting a value of exactly 2, it is less than 2, which means that our data suffers from the problem of autocorrelation. You have other measures of normality like the Hark-Bera test. The probability of the Hark-Bera test is also displayed here, which is 0.4. Last but not the least, we have conditional number, which is on the higher side. The conditional number here is 189. With this, I have come to the end of the price elasticity of demand video. In this video, we have seen the theoretical aspects of price elasticity of demand. We have seen what is the definition of price elasticity of demand. How do we mathematically define price elasticity of demand? Further, we went on to see how do we interpret the price elasticity of demand, and we ran a model which is called as the log-log linear model. I request you to subscribe to my channel, also like and share my videos. I thank you very much for watching this particular video. Have a great day ahead.